Hello, people. Before we start, I want to show you that we do have some practice problems also in the web page, but this is not for the online class though, but I want to use it as well. If you type ASU MAT 210, we always have reviews on the web page. You should not use them, to be honest. Well, you can. It's nice to have more problems to practice, but your practice review is better. Because again, all problems on the exam are from the practice review in my math lab. But today I will copy paste some problems from here because they're good. I just found several problems which look really good. And then I don't have to write them down. For example, I will start from the end. So we just learn all of these things first, and then I will go back to the beginning. The surplus. But this one also has more or less solutions with some explanation sometimes. So that is also good. Let's see. Well, this particular one doesn't have any explanation. The other ones had actually. Yes, you see. The other one actually has an explanation. P and Q. Find the equilibrium price. And you guys just need to remember the formulas. The equilibrium price. You need to solve the system simultaneously. Yeah. Okay, let me do this. First, I'll open this camera. And then you guys have to help me and let me know if I mess up. Because as always, I warn people I don't teach the evenings for a reason. But that was the only free time I had after morning classes. Let's see. So definitely review the problems about equilibrium and surplus. Decrease any activities. Okay. Stop. So how do you do that? Who remembers this idea? D is given as demand, supply is given. How do you find equilibrium? Anyone wants to contribute? We do have the answer, but how did we get it? And there are lots of problems like this, and there may be several you will see on a test. Yeah, Isabella, do you want? I kind of saw you hopping on. Is the camera? Anyone know? So let's yes, set equal to each other. Exactly. Thank you. So if the equilibrium price can be found solving the system of equations when together for P and Q, because equilibrium means you finally match these two. That is the idea. Let's do that. In this case is D and S. D is the demand, S is the supply. So if I write down D of X equals S of X, yes, you guys can definitely unmute yourself. And I'll be checking chat from time to time. 0.3x. They take us back to the solving equations. I usually isolate all the x on the one side. That would be 200 equals 0.5x. X is 0.5 is 1/2. So isn't it just 400 then? Let's check to make sure I don't mess up. So again, if you came late, I'm taking this from this web page. I'll give you these notes. So you have it here. This is number 4. And it says 400. Now, how do we find the consumer surplus and consumer surplus at the equilibrium quantity? CS and PS. What does that mean? Who remembers that?
The cost and the price.
CS and PS. So what do we do to find these two? A, B. Who remembers that? Just plug in S of 400. So we got 400. Yes, yes. I was listening to you. D, so let's, whoever just said first, let's follow your notes. I like that one. S to get P. So we're going to have S at 400. Plugging in into the 0.3 times X, X is 400, which is 12, 0, I think 100, right? So what do you think? What do you think we should do? Any ideas? So I'm following this example. Find the consumer surplus and producer surplus in the equilibrium quantity, CS and PS. Who remembers the formula? This was one of the recent materials. Anyone? Oh, the integral of dx minus qq. Yes, this is what I'm trying to remind you here. So that's why I didn't want to show you a solution right away. Kind of trying to promote you to remember on the flow. So I'm asking you right now, it's nice if you remember. Here are the formulas you need to remember. Producer surplus is defined as the integral. Maybe it will allow me to plug. Oh, nice. So let's build the integral. We need to find P first. We found the P by plugging in right now, right? So that was my price. Then Q minus S of Q. Anyone wants to help me to build the integral? Producer surplus, PS. PS is the integral from 0 to, and then P minus S of Q. Let's go back to the idea here and compare S of Q. Okay, Jeremy, now you just have to keep going then, since you already helped. What should we put here? Come on, people, be active. It's nice if you actually activate it right now. Then you'll feel more confident on a test. From 0 to Q. What is my Q? Let me do it step by step. Let me try to remind you. So let's see from this one. Anyone remembers? Check your notes if you don't remember. Maybe your notes will help you. Yes.
What did you ask?
So we're looking for consumer surplus and producer surplus. Let's do it one by one. For now, I'm trying to write down this integral, producer surplus. I found the formula, which we learned. So can you help me to build the integral? For example, what is P? This P.
P is the price.
Right. So what is the number for that?
The cost minus the revenue equals the price.
So from this problem, how would you find it? Yes, thank you. Yeah. So for this problem, how would we find? We found equilibrium quantity. We're giving demand and supply.
We would subtract.
Multiply 400 by 120.
400 by, where did you get 120? That is this thing. So we plugged 400 into S, which is supply. We got supply at the equilibrium, and we got this number. P, let me do like so. P is 400, which is the equilibrium number we found, equilibrium quantity, times 120. Agree? 48,000. Do you want to explain? How do you know that? Well, I remember that it's a formula, but I think you can kind of understand the idea behind it.
It's 120.
Does anyone want to explain? Well, how do we know that? And then what is our S of Q? So let's keep going with the integral. S of Q is inside over here in the integral. S of Q, what is that? What is our Q? Let's do that. What is our Q? Okay, that's yes. Q, P, S of Q.
Q is 120.
Q is 120. We found it, right? Here it is. So S of Q will be what? Like I wasn't ready to work today. Let's try to review the formulas. Let's see if they have it here. I don't have it here in the review. It would be nice if they just have a whole list of formulas. I can just make a box for you. I already can see the problem. Let's see. Consumer surplus and producer surplus, yes. Let's have and producer. Let's have a box of formulas with you. Of course, you cannot take it to the test, but it will be nice if you have it with you right now, so you can kind of sneak peek, and then in your memory, you'll remember how the formula looks like. I definitely remember this graph. I remember this is where the equilibrium is happening. And all those pieces, they mean something, and the integral gives you this area, which also means something. So, any formulas here? Nope. To add to the notes will be nice. Yeah. Kind of. Oh, this is a good one. So, this is what we're trying to build, this integral, which is the area. And notation can be different from book to book. So we're going to stick to notation we have right now. Integral from 0 to this x is your Q price minus S of Q. Demo here. Yes, the abbreviation, they never helped, to be honest. So let me have a picture at least for you. So let's keep going. Let's finish building the integral at least. Who wants to keep going, finishing the integral? This is my area. So we're finding this area called consumer surplus. Here, this is our Q. From 0 to Q. P minus, and this is our S of Q, D, Q, like so. Q. Yes, so let's finish. Someone was already saying, did you guys
So,
find this formula?
What's S again, I guess?
So we want to find producer surplus.
So what's S? What's the equation for S? Because we have to find the
Oh,
integral
yeah,
of
yeah,
it.
sorry, yeah. S is 0.3x.
So the integral will be 0.15 x squared.
So this, you're telling me S of Q, right? 0.3, sorry, it was 3 times what?
Well, there's 3x, but the integral of it would be.
Oh yeah, let's not integrate yet. I just want to build the integral for now. So it's from 0 to Q. What is my Q?
Q is 400.
Q is 400. So integral is from 0 to Q. From 0 to 400.
Yeah.
Yes.
Yeah.
P minus, what is P? P is the price.
Yeah, this is different than what they showed in the lessons. So.
Oh, that's why you guys stuck. Let me see. That's possible because the books in this chapter, they never agree between each other. So our video is also not consistent. The moment we make videos, they change the book. That is the problem. But I do have, let me see. Well, yeah, that doesn't really matter then. Just tell me the way you learn it.
So then we do the integral of S we calculate S S at 400. So that would be 0.15, 400.
Wait, integral of what do you say?
Integral of S,
Mhm.
right? And so that would give us, and then basically put in 400 as, so that would give us 24,000, and then you minus QP from that, which obviously I think I did something wrong because it's usually not supposed to be a negative. So yeah. Unless you're supposed to do, actually, it might be QP minus 2,400, which no, gives us 2,400. So
what answer did you get? Because I have the answer, of course. Number 4 here. If we're looking for the PS is 24 and CS is 16.
So PS 24, because you did QP minus the integral of S, and then for the other, for C or D dx, it's the integral of dx minus QP.
Integral dx, right?
Mm-hmm.
Minus QP. What is, okay, Q times price, right?
Right.
Okay, and then this one you get 16,000, right? Or 24.
So it's at 200 minus
200 minus Q times P.
So
What is 120?
So that would
120
be,
times
yeah. So then for that, it's
20 times price.
that'd be 64,000, and then that minus the 48 will give you the 16,000.
48 gives you 16,000. And then 48 came from here, like so. Equals. That is my PS. And then how did you get, no, that's CS. CS, consumer surplus. And then PS is 24,000. Which came from, how did you get 24,000? 400 minus QP, right? Integral 400 minus QP.
It was QP minus the integral of S.
Integral, yeah. That is PS. Okay, this is the problem from the test. So you guys, no matter which formula you use, you should do it. Make sure you do it. But I see how they're teaching it differently. Yes, the integral of P separately minus, yeah, I can see the reason. But I wanted to make sure that you understand it is an area where we found the equilibrium. That's important. And then we find the area. So it gives you consumer surplus and the producer surplus. Oh, thanks God. Okay, so that is definitely trying to make sure you will see it on the review. You have these kind of questions on the review. So make sure you definitely understand that. Okay, that was not too bad, but just make sure you're confident with this, because that took a little bit too much time. I kind of was hoping that you already know that. Okay, that's fine. Just now put some kind of fat star for people who have no idea what just happened to review this. Review. And besides, these are the most applicable questions, so I hope you're enjoying this. Now, something which is not applicable were improper integrals. Let's do these. Improper integrals. Again, I made sure that all the questions in the test are coming from the review. So make sure you unlock the review really fast and work on it, or this review I'm giving you right now is also good, so it's fine. Improper integrals were different. One of the easiest one were from 0 to infinity, and then you have, say, 5 e to the minus 3x dx. And then we taught you that, oh, actually integration can be infinite. There are even cool animations we show in class where you have, in this case, exponential function, say going like so. And then I'm finding the area from zero, and then forever. So instead of integral from like 0 and 7 or 0 and 700 or 0 and pi, I'm not fixing the right endpoint. So this x over here, it's keep running forever to the right, to the plus infinity. When x is keep running, the area is keep accumulating. And now surprisingly, if area shrinks fast enough to 0, the number might be finite. And this number is this area over here. Is it finite? Then if yes, you call the improper integral convergent. If it's infinite, you call it divergent. Infinite means not a number. Finite means it's a number. We taught you that limits were involved in the situation, so let's write it down with limits. You write down a limit and pretend that this integral is normal. And by normal, let's do t. Or t or b, people like b actually, but t, so some kind of any number you like. You call it dummy variable, doesn't matter what it means, but you say that t goes to infinity. And now you solve the integral pretending it's okay, pretending there is no infinities there, and then later you will find the limit and see if it's finite or not. So what is the integral? From 0 to t, 5e to the minus 3x dx. I will help you with this. 5, maybe kick it out of the integral. From 0 to t, e to the minus 3x dx. What method do you use to integrate exponential functions with minus 3x over there? This is annoying. This part is annoying because we remember that e to the x gives you e to the x. But what happens if there's a 3 or any number involved? Let me check the chat. Okay.
1 over the value. And
Yes.
then
Exactly. Thank you. You copy, because that's what you do with exponential functions. You just copy them. When you differentiate and when you integrate, you copy them and you divide by that value, just like you said. Usually we say we divide by the leading coefficient. It only works with linear coefficients though. Minus 3x, not minus 3x squared or square root of x. You would write plus c, but it was a limit. So remember now we're going, oh, that's not plus c. A bar from 0 to t. That's a definite integral. Plug the top. And then minus, plug the bottom. So it will be, see how I can factor out minus 3, like so, to the, and merge it with 5. So it's going to be e to the minus 3t minus e to the 0. Remember, e to the 0 is not 0. Somehow it's a very common mistake. E to the 0 is 1. So now everything depends on what this t does. What does the t do? Yeah. Anyway, this t goes to plus infinity. So on this particular moment, we finally remember it was a limit and t is actually exploding to plus infinity. It's literally like explosion hidden in the exponent. Explosion of 5 over minus 3 e to the minus 3t minus 1, because e to the 0 is 1. 5 minus 5/3 does not move anywhere. It's a constant. Minus 1, it's a constant. But e to the minus 3t, now it's a moving object because t goes to plus infinity. And now everything depends on this. Either it explodes to infinity and you say this improper integral diverges, or it shrinks to some kind of finite number. It all depends on the speed. How fast does it shrink to 0? Or maybe it doesn't shrink to 0. Maybe it's like going like so. Then the area is obviously keep accumulating and it's infinite. Here, there are several ways to see, at least 3 ways. My students will keep telling me how they see exponential functions. At least 3 ways you can see the answer over here. So, which one do you know? Let's see. You can tell me or I can tell you. One way, e to the x visually is growing up to plus infinity. At infinity, we know that. But e to the minus x at infinity now decreases. So this is one of the ways to see it. Okay, so I will do it like so. E to the minus x, e to the x at infinity. X goes to infinity. So either this way we know that this shrinks to 0. The other way to understand this, e to the minus 3t can be rewritten as 1 over e to the 3t. Now, when t is still going to plus infinity. When t goes to plus infinity, denominator explodes to plus infinity. But since denominator explodes to plus infinity, you're dividing by the biggest numbers you can imagine, the answer will be the smallest number you can imagine, which is 0. And numerically, you can just plug into your calculator and see 3. If you check in your calculator, what is e to the minus 3 times, I don't know, as many zeros you want, and your calculator will give you some small number, right? So one more way to see, to cheat on a test, is basically using numerical approximations, or sometimes we call it number sense. So these first terms go to 0, then we will have minus 5/3 multiplied by 0 minus 1, which is minus 1, which is 5/3, unless I made a mistake. What do you think? Looks good to me. So those are improper integrals. Improper integrals. Definitely it's going to be there, because or else why we wasted time learning it. Now, this was a good one. Any questions about this? What do you think? Now let's go to more math stuff. Because I kind of have a feeling which things people stuck with. So I will jump around the chapters on purpose, because I think these are more important to review. For example, optimization problems. Optimization problems might be with a backstory or without. Optimize the maximize the profit, minimize the cost, or there is no such a backstory. For example, of all numbers that add to 76, find the pair that has the maximum product. What? So likely they give the equation. The equation is Q, that is objective function, equals x. You know, like I read some kind of wording, and that's boring, not interesting. So I read the math. Math is more interesting to me. They say this is objective function. Objective function, by the definition, is something we want to maximize. And then they tell you also x plus y equals 76. So this doesn't have any background story, even though at the beginning they say of all numbers that add up to 76, find the pair that has the maximum product. So we want to maximize the product, and we call it Q for no particular reason. What do you do here? Those are called constraints. Constraints. Does this ring the bell? So this is called mathematical model that has two things, objective function and constraints. Constraints are restrictions. So any product can be infinite, but x plus y is 76. Now that's a restriction on each variable. For example, total number of cups and pens you bought is 76. Done. This is the constraint. Usually we teach you like this. Step 1. This was example 1a. Step 1, solve second equation. Let me call it equation number 1 and equation number 2. For one of the variables, whatever is easier, in this case, it doesn't matter, so I will solve for x. X is 76 minus y. Plug into Q. Equation 1 will, plug into 1. In this case, it's equation called Q. Q will be x, which is 76 minus y times y. Nice. Now this is a function of one variable. Let's distribute 76y minus y squared. That was B, C, optimize it. Now calculus starts. So before that, it wasn't a calculus. That is interesting observation. Now calculus starts. How do we optimize things? We have a whole list of steps. Step one, find a derivative. Derivative gives us critical points and that kind of thing, all this stuff. So let's have Q prime is 76 minus 2y. Set equal to 0 to find critical points. Critical points called critical because something is happening there. For example, derivative is 0 or D and E. 76, let me not skip the steps, minus, oh, actually, it's fine, equals to y. Y is 76 over 2, 38. Kind of, you're supposed to prove that this gives you the optimal solution, but I don't know. I mean, there's no other options, right? So how would we have any other options if there's no options here? But to be honest, yeah, you're kind of supposed to check with the first or second derivative test, if you remember that, which is sideline for Q prime. You put this 38. If we know that we plan to maximize, we know it's going to be plus or minus. How do you do that? You take test points like 0 and 100, plug them into the derivative. In 0, it is plus, at 100 is indeed minus. Original function Q is increasing and then decreasing. Visually, this is how I teach it. You can see it's maximum, hiking up, hiking down. But again, like there's no other point. So they ask us the question with 1 point as the answer. It probably is the answer.
So it's 38, not 36 on the bottom there where you're at.
Oh, thank you. Yeah. Thank you. Good catch. So now you found Y, find X. So it's going to be the last step. We kind of found what going to optimize it. C, D. X was find where I solved for X. I usually recommend putting in the box so you can find it later. 76 minus Y, which is 38. 76 minus 38, which is 38 again. Okay. So 38 plus 38 gives you 76. And we want to find the maximum product, which is 38 times 38. Q will be 38 times 38, whatever that thing is. Kind of makes sense, to be honest. It was a dumb question in the first place because yes, obviously you take the biggest numbers and then when you multiply them, it will give you the biggest product. But anyway, that's how you do it using calculus.
Well,
So
that's what I always wondered. Like, it's just 76 divided by 2, and then you multiply each other. Is there ever a time where it's not, X and Y are the same?
With more restrictions, negative numbers will be
but
tricky.
not right now, right?
No, that's fine. It's a dumb problem, just kind of shoving you. Especially if you think about money, you have dollars and dollars give you 76, multiply them. Of course, you take half and multiply the half. That just makes sense to do it this way. Now it's just this kind of stupid problem. But it's fine. So let's see. This was a good one, but some of them will have a backstory. Some of the problems will have a backstory. Remember what backstory we had? We had stories where very typical business class in Q11, if you plan to take Q11, you will have more of these. Maximize the profit. That's literally what we always teach again and again, which makes sense. So that's why we teach business students calculus in general, because there's lots of things you can do to maximize profit, minimize the cost, find investments in 10 years and maximize the investment and so on. So with the backstory, example 2, maximize profit or minimize the cost. That means you need to remember relationship between profit, cost, and revenue functions. Profit of X, where X is a number of created and sold products, is the money that you received that makes you happy, minus the money that you lost, like utilities, or maybe just producing the items. So it's a difference. Makes sense. So break it even phrase means when these two match, and finally your profit is 0. So people want to strive to get at least 0, and then profit increases after this, hopefully, if your business is good. So these problems, let's see. I just give you random stuff and then you have to figure out revenue and some kind of backstory. Don't waste your time reading too much. It says, oh, we were producing and selling cups or ice cream. I see the equation. R of X is 10X. That is revenue. Cost function is given as, for example, the quadratic function, 0.03 x squared plus 0.2x plus 10. Boom, done. What is the production level for the maximum profit? And what is the profit? So they want us to find X and then plug it in to find P. But again, maximum one. So not just profit. Let's see. The question is maximize. Let me finish the way they say. What is the production level for the maximum profit? What is the production level? You saw it in your homework. Production level for the maximum profit? Question mark. When you see the maximum profit keyword, you immediately know they're talking about derivatives because that is optimization problem. So you see, until I saw the maximum word, I did not know that. And then I saw it and I like, oh, they want me to differentiate P, not just plugging things into P. And then this is A, and then B asks to find the profit. What is the maximum profit? Let's do that. Step one, solution. Step one, let's find profit from the equation I just gave you. P is R minus C. So it's going to be 10x, that's the one that made you happy, minus, don't forget to change all the signs, 0.03x squared minus 0.2x minus 10. Simplify, which means collect your terms. Minus 0.03x squared, always put the highest power first, minus 0.8, no, 8.8. 8.8x and minus 10. So only two terms were collected. That is a parabola.
9.8.
Yeah, 9.8.
Oh, thank you. Good catch. 9.8. That is a quadratic function. So two ways of seeing it. Either you actually differentiate and find the maximum by setting equal to 0, or you kind of know that the quadratic function is concave down, which means it's looking sad, like so. When this first term is negative, so it has a maximum, and the maximum point actually has a formula. Not only it's called a vertex. The formula for x is minus b over 2a, and that's why I ordered them, because this is my a, this is my b with a negative sign, this is my c with a negative sign. So technically speaking, you can actually don't do calculus here at all. It is algebra here. But maybe it's faster to differentiate. So maximum profit will be found if I differentiate P minus 0.06x minus 9.8 equals to 0, or D and E. There's no D and E here. X equals 9.8 divided, is it negative? 0.06. Oh.
It's plus
9.8
9.8.
would be positive still. That's what I was wondering too, because I always thought it was negative, positive, negative, or positive, negative, positive, right?
Yeah, because the 10x is positive. So it'd be a positive.
10x is positive. Oh, thank you. Yeah, good catch. This is the one. This is the positive, because x should be negative. That's how I caught my mistakes. Yeah, I think good. Good job.
Well, isn't that right? Isn't it? It should always be either negative, positive, negative, or positive, negative, positive, and so you should never have all three signs the same, right?
Well, in general, yes, but for the profit to have any normal solution, no, definitely, because
Right,
this is the shift left and right. So this is better located on the right side of x and y. Well, in this case, it's p. What else? It would be negative number of cups we're selling, or negative number of cars and stuff. Yeah, good point. Yeah, that's exactly how I caught the mistake. It doesn't make sense to be negative. So we got this number, whatever it is. I need to figure out what it is. This answers X. What is the production level for the maximum profit? That is how many X are we?
163 and 1/3.
153,
63.
63 and 1/3.
Yep.
Thank you. Nice. So, in the number of units that must be produced and sold in order to yield the maximum profit is X. And this is what we found. So X gives you that maximum profit. And then it's like, what is the maximum profit? So step 2, plug it back into your profit. P of 163 and 1/3 equals to the original. So students usually like these problems, these types of problems, because it's only 2 steps and you know what to do. Here you plug into your P, which you created over here. Put it in the box as well, not to lose it. Minus 0.03. And so make sure you calculate it ready, because that will be annoying to calculate. And they never give you good numbers, I checked. It's always some kind of fractions because they want it to be realistic. So I will, in my classes, I give nice numbers like 5 and 7, but to be realistic, yes, they do some kind of stuff. Now the question is, this is done, but I wanted to let you know that if you do minus b over 2a, because it's a parabola, it will also work, because this is literally minus b over 2a. Look at that. That is minus b is minus 9 over 9.8, and then minus 2a will be minus 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 2a is 0.06. So vertex also works if you want to use that formula, but it's only for parabola stuff. Doesn't work for anything else. Parabola. Okay, checking the chat really fast. Plus 9.8, good job. Okay, good. And now the long problems. The long problems that has a backstory again. But now they want you to find total revenue, total profit, maximum profit, plug in, and so on. So that is the one that doesn't give you PR and C right away. You remember these types of problems. And it's still optimization problem. Example 3. Let me see if I can find it in here. This is the one they give you cost and stuff. Oh, I just need to check it here. Just a second. So plus. And then you have to multiply your cost by the price. Yeah, to figure out. So let me do this. Okay, this looks good. Here it is. Final exam review. And it's a long backstory, so I skip all the background of that. I can see that they talk about company, closing firm, and whatever. And I see equations. Yay. P is 190 minus 0.5x. And then x is always producing something. In this case, suits. Cost is given 3500 plus 0.75x squared. And that's all they give you. But kind of, if you do these problems long enough or many times, you figure out the pattern here. Questions. A, find revenue. And I can find it right away for you. Revenue is what? If it's not given, it's, what do you think is revenue?
X times P.
Right? It's X, number of units we have, times the price we're spending per unit. So cost will be used later because cost is the one that makes you sad. Revenue is the happy one. So we're gonna sell X cups with the price we choose, which is modeled by 190 minus 0.5x, in this case of suits. Simplify 190, it's not simplified, distribute 5x squared, and this is my revenue. Put it in the box. Now we have three functions again, and the story repeats. They literally ask you the same thing. Find the profit first. Profit is happy revenue minus set cost. In this case, we have two quadratic functions. So make sure you have parentheses ready or change all the signs accordingly. Minus, this is my happy function revenue minus cost function. Change all the signs. 3500 now is negative and minus 0.75x squared. Simplify 190x and collect the terms better in order. Minus 0.5 and minus 0.75 minus 125, right? No, too late. It's too late in my mind. 5 plus 7 is 12. Okay, yeah, I was right. Agree, yes. Well, nobody said anything, so I guess it's good. And plus 190x minus 3500. And then they ask you to, so we found total of how many suits must the company produce and sell in order to maximize the profit. Maximize the profit, and the whole story repeats. So I'll just give you the steps and you know how to do it. Profit P prime, or you do the vertex if you want, minus B over 2A. P prime equals to 0, solve for X. X gives you this happy number, plug it in, gives you the maximum profit. So, good. Yeah, that's kind of all, to be honest. What price per suit must be charged in order to maximize the profit? In the price, so you can also plug this X back into your P to find the best price to maximize the profit. Does that make sense? So the whole story repeats. That is a story with the background, the problem with the background story. Okay, keep going. Let's see. Yeah, practice again. If they ask you to find R prime, C prime, P prime, do you know how to do it? Yes. Well, we can do it if you want. If they ask you to find how fast the revenue is changing, you differentiate your revenue. That's why putting in the box is convenient because I know I'm looking over here. 190 minus X, that is derivative for R prime. So if they ask you to find C prime. Where's my C? Here it is. It was given 0 plus 1.5x. Done. How fast the cost function is changing. Figure out that. If they ask you to figure out the price at 75 units being sold, plug in 75. Revenue, plug in 75, and so on. So these are very good questions. Usually students do really well here. Don't be afraid to see lots of A, B, C, D, E, F, G questions, because all of them give you partial credit, and it's fine if you mess up one, you might not mess up the other one. That's actually good news. Good. Now, do you remember how to do implicit differentiation? Yeah, your favorite topic. I know students do not like implicit differentiation. It actually depends. Some people do, some people don't. So if you know how to do it fast, usually you like it. If you keep making small mistakes, you don't like it. So it kind of makes sense. Let's do one of the questions from the review. Here it is. Oh, and we need not to forget to also review if we have time, because definitely I can see it's a big exam. elasticity in inelastic, elastic, and so on. Those are cool topics. I actually like them a lot. Let's do implicit differentiation first. Implicit differentiation. Implicit differentiation is happening when you don't have a nice written function. For example, for profit, we had a profit function, la, 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 so we could find P prime. Well, what if we don't have profit function equals blah, blah, blah? What if profit function is hidden like P cubed minus R squared minus X squared equals 13X? Well, how will you find P prime then? Or any function? That is called a function is not given explicitly, it's given implicitly. So the differentiation should also happen implicitly, not explicitly. For example, if a function is hidden like so, sometimes you just cannot even solve for y to find y prime. Then you do it implicitly, and they ask you, find the slope. You remember the keywords for the derivative? I think I was showing you this in my previous review. Find the slope. The moment you see how fast or slope or rate of change, that is a derivative of the curve at the given point 2 and minus 5. So this is a keyword that you need to differentiate. And that's why you know that they're asking you for y prime at 2 and minus 5. That is your slope m. Slope m. Let's do it. Implicit differentiation is when you just bombard the whole equation with differentiation. The difference is when you work with y, you will use chain rule without really understanding it maybe. Y squared gives you 2y. By chain rule, you do times the derivative of the function inside. The function inside is y, so that's y prime. So I always explain it like this. Y is a cool function. And that is why every time you see any function with y, y prime gives you y prime or dy or dx. While x is not a cool function because it's independent variable. X prime is 1, so see the difference. Y prime is 1 times the derivative of the function inside, which is y prime. X prime is the function inside, so it's just 1. That is a difference. So y squared is 2y times y prime shows up, while x cubed is 3x squared. So that is a difference. Equals 17, find the mistake.
It should be 0, not 17.
Should be 0. I always show this mistake because people do it. They get excited that they finish differentiation and forget the right-hand side. So make sure you differentiate everything. Yeah. Thank you. And now the process starts. I always teach it like so. Identify pieces that have y prime and move them to the left. This piece is already on the left, so I will do it here. I will keep it. Everything else is garbage. Move it to the right, like so. So it will be equals 3x squared. One more time, identify the piece you're looking for, which is y prime, and factor it out. Y prime, put brackets. This is how I teach it. 2y and many more pieces if you have more. In this case, it was already factored out. Equals 3x squared. Divide by those brackets and you have the solution. Y prime equals right-hand side, RHS, over those brackets. So it's always the same pattern if you really want to be fast. It will be 3x squared over 2y. Many students learn how to figure out the faster way. The idea is you are solving for y prime. So you isolate y prime. All this process, we're solving for y prime, and this is the best technique to do it. Isolate all the pieces with y prime. Factor out y prime to be completely isolated. Get rid of the brackets part. So divide by that. And that is the answer. As you can see, the answer involves y, which is unusual that we have unknown y in the answer. But that's what implicit differentiation is doing. This is given as x and this is as y. So the second step is to plug in. Step 1, we found a derivative. Step 2, we're plugging into the derivative. 2 and minus 5. 2 and minus 5. you can sign it with a pencil, not to mess up, that x is 2 squared and y is minus 5. So the answer is 2 times 2 is 4, 4 times 3 is 12, divided by minus 10, simplify minus 6, 5, 6. Like so, implicit differentiation. So kind of steps are usually the same. So if you practice a lot, you do really well. What do you think about this? And I will show you the hardest part is definitely finding those derivatives. So let me briefly do one more example, but very beginning of it. If you have 7xy minus 4x plus y equals minus 11, this is product rule over here. And this is where students stuck. The product rule or quotient rule. Product rule because here x and y are both variables. X is independent variable, y is dependent variable. Y depends on x, and that's why chain rule is involved. So let's review product rule. The way I teach it is u times v, derivative times not derivative plus not derivative times derivative, or whatever order you like. So if I see the 7x times y, not necessary, you can see the 7 outside and x times y. That will be derivative of 7x is 7. That is, I'll order it like so. U prime, that is 7. Times copy v. So let me say u times v. V is y plus copy u, that is 7x, times derivative of y is 1 times y prime. Every time you differentiate something that holds y, y prime shows up, or dy over dx. You can write it down as dy over dx if you want. I will do it right now for you to understand it's the same thing in this class. In upper level class, it will be different. So this was only piece highlighted here. It's product rule. Thus, this first piece is 7y plus 7x. Let me write down once dy over dx. I usually don't do it because it takes too much time. Minus derivative of 4x is just 4, plus derivative of y is y prime, which is dy over dx, equals not minus 11, but 0. And the process is the same. See how I will do it. Keep or move things with dy over dx to the left-hand side. And if you can, factor it out right away. That's what I would do. I would factor out dy over dx right away, open the brackets. Who is staying in the brackets? 7x plus 1. Factoring means dividing. So dy over dx over dy over dx is just 1. Equals, move everything else to the right-hand side. That's garbage. Don't forget to change the signs. So you will have minus 7y plus 4 divide by the brackets, and that's the final answer. Right-hand side over the brackets. 7. You can start typing it. I would do that if you're like afraid of lack of time. I would start typing right away because I know it's going to be right-hand side over the brackets.
Does 4 minus 7y over 7x plus 1 make a difference?
No, I wanted to do it first, and then I said, let's be consistent from left to right.
Yeah, I just wanted.
Yeah, I also wanted to do 4 minus 7y.
Yeah.
And then and then you plug in the point they gave you. So that's implicit differentiation for you. Be careful with that. That is good. Let's see. Okay, related rates problems. Yeah, these are not too bad, and we could do some integration as well. Related to rates problems are. Also, I just found one more problem. Rate of change of the revenue, differentiate. Remember the keywords. Let me point out again. Slope. Let me point out at the very beginning somewhere. Maybe after this, yeah, optimization problems. Every time you see words like find the slope, rate of change, maximize or minimize, optimize. You know what to do, you differentiate. F prime. This is what they wanted to do. Because I see they're asking find the rate of change of the revenue. Don't be afraid, differentiate the revenue. It's a simple function over there. Cost, differentiate the cost. Profit is not given. Find it first, differentiate. Plug the points they give you, done. So I think this is good, we can do. Okay, how about these problems? Related to rates problems. I teach it with also a volume of the sphere or something like this. Luckily, they give you the formula. For engineering classes, they don't need to know the formula. So related rates. Related rate is a very applicable thing in statistics and business and data science, because functions actually are related and they all changing at the same time. So that gives you several rates which are related. For example, we give you some kind of watermelon. it's over there, but I don't know, a sphere, a ball. Okay, yeah. So we usually say a balloon is keep growing. Maybe that's what you saw. So it's a ball. A ball has a volume and kind of you're supposed to know it, but it's fine. It's 4/3 pi r cubed. So they give you that. The radius, and now you have to be careful how you read the problem. The radius is growing. So the radius is changing. That is one of the rates. At the rate of 0.6 centimeters per week. I see per. So one of the keywords which I should add over here will be per. Either you see slash or per. That is also indicating a rate, or they literally say a rate. So that is immediately a keyword, that this is a derivative of the radius, not the radius itself. And that's how you know the difference. The radius is growing at the rate. So again, I see slash, I see the word rate. That gives me the idea that this is not r, this is r prime. That's how you know. At a time when radius is 7.7 centimeter. Wait, so it says radius 7.7 centimeters. There is no per, there's no slash, and it doesn't say a rate. So that is r. And that's how you read the difference here. What is the question? So for now we have one. I'll start listing what we have and then I'll post the questions to skip some space. It says r prime, or it's better to write down as dr over dt with respect to time in weeks, is 0.6, while r is 7.7. So I have one rate only. It means there should be another rate, and probably that rate is not given. And this is exactly what the question gives it away. How fast is the volume changing? Question mark. At that moment, it says. That is a keyword again. Changing, rate, and how fast. How fast something is changing. So they don't ask me for the volume. They ask me for the V prime. That is the missing second related rate. dV over dt is unknown. The moment you see this, that's related rate problems, you find, locate the formula, differentiate it. Using implicit differentiation, by the way. This is why this problem always goes after implicit differentiation. Because again, you treat both functions like functions that are related with respect to t. So actually it is v of t equals 4/3 pi r of t cubed. You're just bombarding all of this with derivatives. V prime is dv over dt, it's not 1. 4/3 pi, 3 goes down, r squared times the derivative of the function inside. That is implicit differentiation or chain rule happening right now. It's like y prime pops out. And those are two related rates. They showed up from the equation. And now I can ask you to find any, either dr over dt with the given dv over dt, or vice versa. From the list I just created, it means I actually need to find dv over dt with the given radius 0.6 and the given rate, no, radius is actually 7.7 and the rate is 0.6. Make sure you don't plug it right away. Your r should not be plugged in too early. You plug it only after you differentiate. dv over dt is 4/3 pi 3 times 7.7 squared times 0.6 equals, and I have the answer 447. 447. The volume is changing at the rate about 447, and now you have to choose the units. Yes. Guess the units without a list. Do you know what the units? Volume is supposed to give you a hint. Volume is measured in what?
Cubed, isn't it?
Yeah, so you just need to find what was it? Centimeters. So centimeters cube per t was in weeks, but like, is it weeks squared, cubed, or just weeks?
Just weeks.
Just weeks. This is how you should see it. V is the volume, so it definitely is changing cubic centimeters. One more cubing, literally cube, centimeter cube. It's a cube. 1.1.1.10 per what? Per 1 week. So weeks do not change here. That is important.
On this one, I always just think 4 pi r squared, right? And that's never a different answer. Is that correct? I mean, it's always going to be 4 times pi times the radius squared and then times the rate of change, or no?
Yeah, you're right. Yes. Definitely, because we don't want you guys to have complicated problems in the
The
test. So
threes cancel out, right?
yeah, the 3 cancels out. No, he's right. Yeah. That's true. There are patterns. I always see them, but I try not to mention them too much because with different
Well,
functions, everything.
Like I'm really good at the patterns, but I don't actually see where they end up sometimes. So I'm trying to ask my question.
Yeah. No. Patterns are good on the test. I like it. I teach patterns for students to be fast, so that's good. But different functions, they will have something different. How do you guys feel about this? If okay, I would like to move, unless you stop me, to integration. Thank you. Let's do integration because this is the one students stuck. It was also at the very end kind of thing. Well, not very end, but quite a lot at the end. We did improper integrals already. If you came late, you'll check it out later. But integration, using integration by parts. Let's review that because I'm kind of thinking that elasticity demand you can review by yourself. It's just one more formula, and I think you're good at those things. I noticed business students are pretty good at formulas because statistics has lots of formulas, so you know what you're signing up for. But integration and stuff that has lots of steps and students stuck sometimes. So let's do that. Integration, and you can ask me what the heck is going on. Especially use substitution integration by parts. Integration. But still, at the end, I will mention, don't forget to review the system of demand and some other things I will say. Let's just do several examples. I will go fast and then you stop me if it's too fast. Your job is to figure out, you need to reflect or basically ask your brain, are you okay with this? And if you say, if your brain says no, let me know and we're going to figure this out. Integral of 3 over x. I actually let me ask you, what do you think is there?
1/4 x to the 4th. No.
Oh, that's 2 over x cubed.
Oh.
How about 3 over x? You're very right, but not yet. How about 3 over x part?
3
X to the
ln.
-1.
No, but integral of that.
Yeah, 3 ln x.
ln x. Good job. So this is where students get into trap. Remember, power rule says x to the n. And doing power rule when you integrate, you add 1, divide by this number. However, there's exception. If you have 1 over x, you don't do it anymore. So this works only for x, not -1. That exception gives you log, absolute value of log, because x can be anything, but inside of the log, x should not be anything. So absolute value fixes the negative number situation. So remember these two, that is important. 3 times natural log of x plus, and now you mentioned that was, I think, correct. I forgot what you said, to be honest. So take a pencil and rewrite 2x to the -3. That will help you out if you do that. It's a small step, makes it better. Then integrate that using power rule. It's the same idea. You add 1 and divide by the same result. So it will be 2x -3 plus 1 gives you -2 divided by -2. And don't forget plus c. Do we have a type plus c? No, I think it's there. But don't forget to type it. Oh, you have to type it. I can see. Okay, fine. Don't forget to type plus c, and it's capital C, okay? Cancels out, so it will be 3. You don't have to simplify. I put 100% in the settings for non-simplified answers. So I did it today in the morning. Minus, you can rewrite it as 1 over x squared, but you don't have to. I never do, to be honest. Plus c. Plus c, though, is important. They will take points off if you don't put plus c. I do plan to go and check it, but it would be nice if you like plus capital C. Then I don't have to go check. Formulas, what do you think about this? How about, oh, that's actually is interesting. So, and really fast, let's do this one. Area under the graph. 2. Actually, let's not do any areas yet and just go to the integration by parts and use substitution. Average value, of course, review average value. And this integral of E8, is it 8? It's 9. 9x plus 8 dx, like so. We did it today. Let's do it again. They are shortcuts. I have a YouTube video on those shortcuts, but I can write it down for you right now really fast. Integral of, let me see which one to start. Sine and cosine, we did not really do that here. Integral of 1 over a plus bx. That is still a logarithmic function. Yes, it's still an absolute value of a plus bx. Chain rule tells you times b, but we are undoing chain rule, so over b. That is what is happening. It's still kind of 1 over x function. If you imagine you don't see these guys. But since they're there, you'll have to divide by the leading coefficient, which is b, and of course plus c. One more shortcut is the power rule, a plus bx to the n. Same thing, actually. You raise all of these things to the n plus 1.
You want to take a shower first, please, Gavin?
N plus 1
Anytime. You don't have to do it right now.
over n plus 1. Someone is not muted. 1 over leading coefficient b, like so.
Always in free agency. He keeps getting cut.
Well, you cost too much money, bud. After a couple of years, I mean,
No,
like the
3
Buccaneers.
weeks they cut him.
Gary, you have very cute discussion there.
So, yeah, second
Sorry.
No, at all. So, and then I was smart. I just took my shower. Then let's see. Exponential function, we just did it. E to the ax plus b dx. We did it in the problem at the beginning of this review, which is copy. That's not the copy because I've only denominator. Copy the whole thing. We remember this over the leading coefficient plus c. So those are shortcuts, and there's shortcuts also for the sine and cosine, but we don't really do in this class, and so on. These shortcuts will help you a lot. You don't have to memorize them, but honestly, my students always love these. They say this was the best hint in the class when we do when we want to avoid U substitution. These shortcuts are coming from U sub. So I call them U sub shortcuts. Not all instructors teach them, which is kind of upsetting because for exam, it's priceless. It saves lots of time. Remember, you can always check your answer by differentiating the result, and it should give you this if you differentiate the result. If it doesn't give you that thing, then you messed up. So this example is copy e to the 9x plus 8 divide by 9 plus c. Done. So fast, but actually they expected you to do U substitution. But what I did, I copied and divided by the leading coefficient. Let's use substitution shortcut. And I will do your substitution in a second, don't worry. But this is good. This saves lots of time and effort. One more example when you cannot avoid doing your substitution will help you to understand how to do your substitution, which is 7y to the 8 square root 2 minus 7y to the 9 dy. It is fine that function inside is called y, not x. It can be called g, t, the letter of your name, anything. So don't be afraid about that. U substitution is used when one part of the integral looks like a derivative of another part. Looks like, so times or over some kind of constant. Because U substitution isn't doing chain rule, and chain rule is derivative times derivative. So I can see that this part, 7y to the 8, kind of is looking as a derivative of this part inside of the root, 2 minus 7y to the 9. Because if you differentiate that, which we are going to do right now, let's call this u. If we call everything inside of the square root u, and we differentiate it, which means we find du, it will give us minus 7963. I need to do it in Russian. Somehow you cannot switch. The moment you learn in your own language, it's impossible to switch a table of multiplication to another language. Y to the 8. See, I just needed y to the 8 part. And there's a dy over here. This is one way to see it. One piece is a derivative of another piece. The other part is we don't like square root of complicated things. So it makes sense to call thing inside to be u. So everything becomes square root of u, and we know how to integrate square root of u. That is also a nice hint. The square roots or sines or logarithmic functions of some kind of stuff, that is a hint that you probably are expected to use U substitution. Now it depends how you learn it. There are two ways of learning it, and I will explain you usually how the book teaches it. You solve for dy, because we only need equation 1 and 3. We don't need equation 2. After all, we need dy, because we are going to plug u over here, and we need to also find dy to plug it there as well. Dy will be minus 63y to the 8 over what I'm doing the other way around. Du over minus 63y to the 8. And this is not a constant. This y to the 8 and y to the 8 will cancel out. That's kind of the whole goal of your substitution. I usually don't do it this way, to be honest, but students like this way, the way book explains, because it's very technical, so people get. Integral, let's write down the square root first. The square root of u, nice. Now, dy is du over this thing, du, what stays? Y to the 8 cancels out because we have y to the 8 over y to the 8. But what is not canceling out, and let me put it, I would put it outside of the integral right away, but if you want to have notes, it's fine. 7 over minus 63. This is the part when students get confused. 7 was from here, over minus 63 is over here, because dy is du over y to the 8. Y to the 8 got canceled out. So the integral becomes a very simple one, minus 7 over 63, integral square root of u du. I said very simple one, but maybe it's not. So let's see if you remember how to do it. What do you think about this? Ask me. I don't know. That's not the answer, but I wanted to stop for a second. Okay, if you feel good about this, then it's u to the 1/2. Take a pencil, write it down carefully. And then you know what is that? U to the 1/2 is 1/2 plus 1, and that is 3/2. U to the 3/2 divided by 3/2. I would change U right away, but to give you good notes, I will do it in the next step. Remember, U was created by you. Only you know what U is. 2 minus 7y to the 9. So it is wrong to give the answer in the U notation. It started with y, it better be ending with, in terms of y. 7, negative 7 over 63 multiplied by 2/3, because you're flipping the fraction in a denominator. And now you have 2 minus 7y to the 9 raised to 3/2. Don't forget plus c, which was over here, plus c. Yeah, you can simplify the coefficients, but again, I put, let's see. I put all the good, whatever. Oh, in the settings, I made that not simplify answer will work as well.
So I see the pattern here again, where it's the 7 times 9 is 63 on the bottom. Is that always the case? Is it
Let me check. 7 times 9, 63. Yeah, that is the case because 7 times 9 will be derivative of u. 63 will always go to the bottom because we're solving for dy. Yeah, you're right.
Okay, thank you.
You probably like puzzles a lot. That's me. I guess.
Maybe I just see numbers better
Yeah.
than actual explanations.
That's interesting. Pretty cool. So this is U substitution, and this is going to be classical, something like that will be a classical example on a test because it's either a shortcut U substitution or the one we just did, or logarithmic function, something like that. So don't be afraid. Now, integration by parts. Pom, pom, pom. That is a massive important topic, which we teach in all calculus classes. Integration by parts is unlike, there's my PDF. Unlike U substitution, let me write down. U substitution undoes chain rule. So ironically, U sub undoes chain rule. Ironically, chain rule was harder for you than product rule. But somehow U substitution is easier than integration by parts for many. U substitution undoes chain rule, while integration by parts, that's IBP, undoes product rule. That is harder, surprisingly, to undo differentiation of a product. And it's harder because functions can be all random, so they don't have any correlation, and that is kind of different story. For example, 3x has nothing to do with exponential function to the 2x. Sometimes it does, if it's 2x squared, for example, then it maybe has a correlation. But in this case, none of one piece is not a derivative of another piece. None of it looks like it has a connection. So I'm going to do integration by parts. Did you guys learn liate? I posted my videos, so might be it. Liate is a very nice trick, which I learned in the United States, and it was so upsetting that I never knew that, and I was struggling a lot. Liate. How to choose your U for integration by parts. U choice. So liate tells you choose U to be whatever goes first in the list. If you see log, logarithmic function, choose that to be U. I don't see any log. If you see any inverse functions like arcsine, sine minus 1, for example, choose that to be U. I don't see it here. If you see any algebra, zoom in, like x squared plus 5, choose that to be U. And this is what I see. I see 3x. So this immediately gives me choice. But let's keep going. If you don't see any of these three, but you see trigonometric function, that is sine or cosine, whatever, choose that to be u, and only last in the list should be chosen u as exponential function, because it's the worst one. Exponential function, when you differentiate it or integrate it, doesn't help. So that's a recursive case. Lia, is amazing because I was always guessing, kind of trying to find a pattern just like you do. And it takes so much time. You try, you're wrong. You try again, you're wrong. So Lia actually is an amazing tool, and surprisingly not all books teaches. 3x times e to the 2x. I'm choosing u to be 3x. Integration by part is interesting because you perform differentiation and integration at the same time. Let 3x to be u, du will be 3 dx. Everything else now is required to be dv, so it doesn't have a choice. You don't choose dv, dv is everything else. dv is e to the 2x dx, and now you integrate. Integral of exponential function is exponential function, and then you divide by the leading coefficient if there are any. So I divided by 2. Let me highlight, divided by 2. That's a shortcut of u substitution. The formula tells you, if you organize it as this table, which is very international patient, surprisingly, this is how people organize it in Europe and Asia and in America. Kind of people agree on this. You don't have to, but if you organize it this way, visually the formula is cross product. So that is 3x times e to the 2x over 2 minus bottom product inside of the integral. So this piece, e to the 2x over 2 shows up twice. You can copy it right away, but inside of the integral, and multiply by 3 dx, that is du. So the idea of integration by parts is to break a complicated integral into 2 pieces. One piece is ready, this is integrated piece, and hopefully the easier integral, which is the case. Let's do it. Let's simplify, I guess. 3/2 x e to the 2x, this piece is ready, minus, and now you're integrating exponential function, and we know how to do that. It will be 3/2 copy exponential function, divide by 2 because it's a leading coefficient. Don't forget plus c. Plus c. My tablet is overheating here. What do you think about this? So this is very classical example of integration by parts. We're not going to give you anything weird. These are all very classical examples. So just practice them. Whatever I just did is actually pretty good.
It's called integration by what? I'm sorry, I didn't hear you.
Oh, integration by parts. Let me write down. Thank you. Integration by parts. I can try to speak louder. I think my speaker is on.
No, you're good. Hey, can you simplify that answer or no?
No, I mean, it's over 3 over 4 if you want.
Yeah.
Oh, you could factor out exponential function, but I always say factoring something is not necessarily simplification. So
I just always get a slightly different answer. That's all. Where it would be the twos go away or no?
No, not supposed to.
Okay.
They will get together as 4. I can see that. Yeah. Don't make sure you don't make a mistake. Don't multiply by 2 by accident. You divide by 2.
Sure.
And since you already done this before, it will be times 2 one more time in the denominator. How about this one? Let's do one more because these 2 are very classical ones. The classical integration by parts examples. Oh, I missed it. Yeah, this was number 1. The classical integration by parts examples are products of 2 not connected things.
There's a plus C on the end of the last answer. Just in case nobody's on here.
Magical. It just disappeared.
Well, you know.
My tablet definitely is glitching.
No, you're good. I just wanted to make sure I was correct with it.
Good job, yeah. So 2 things which are not connected being multiplied, that is integration by part classical example. For example, some kind of polynomial and logarithmic function. No correlation at all. And this is how you know it's going to be integration by part. By parts. Let me do it fast this time. Li Ate tells you Logarithm, you see logarithm, that's it. You choose it to be u. Liata says logarithm is the best choice for you. For you to be you. Ln is x. No, u is logarithm x. Du is 1 over x dx. Remember the formula, that's the exception, right? Everything else doesn't have a choice. It is dv. dv. dv is x to the 8 dx. So we have to integrate that. X to the 9 over 9. And we don't write plus c because it cancels out anyways. Cross minus bottom equals sign. X to the 8 times natural log becomes ln x times x to the 9 over 9 minus integral of the bottom part. X to the 9 over 9 times 1 over x dx equals. The first piece is already done, ln x. You can even keep it as it is and start typing it in your solution. The second part have to be integrated. Looks kind of weird, so let me rewrite it with a pencil. It is, I would kick out 1/9 outside, and it's going to be x to the 8 dx, because 1 over x decreased the exponent by 1. Cancel out a little bit. 1 over 9 is standing in front. X to the 8 again becomes x to the 9 over 9 plus c, and this is the answer. 9 times 9 is 81, but you can keep it as it is. So that is one more integration by parts example. What do you think about this? Keep going. This was good. Oh, this will be long. You should do it by yourself, I guess. See what's left. Definite integrals and average value. Kind of lots of stuff left. Let me tell you what you can do by yourself. It's long to explain, so I would give it to you because we have only a little bit time left. So let's see. Review by yourself. Because there is at least one problem there, definitely, since we tortured you so much with the left endpoints, right endpoints, midpoints, but there will be no midpoints though. That means it's going to be on a test. So we're going to give you the integral, for example, from 3 to 5, 1 over x plus 4 dx, and tell you how many points to use in, not points, how many intervals, is number of intervals to use. Do that by yourself. That will take forever to explain, but I do have videos on this, so I can post videos if you want. At least one problem will be there, including what is the average of ln and rn. This is pretty pliable kind of data science problem, to be honest. Let's review this one. The average value and definite integral at the same time. But for you to understand, maybe I let's show this. They give you the interval. Definite integral means there's an interval from 3 to 5. And the function is floating above that integral, whatever it's doing. We want to find the area below that function from 3 to 5. The function is 1 over x plus 4, using 8 points, endpoints. That's just quite a lot, to be honest. That's a bad example. Oh, it's not 8. I did not see. It was 4. That is way too many points. That's why I was surprised. 4 points, thanks God. So, 8 points. If you want to have 4 points, you find this distance, 5 minus 3, that's a 2, and divide by 4 points. 2 over 4 is 1/2. 2 over 4. So the step size and number of intervals, 4 intervals, 1, 2, 3, 4. Visually, I can draw it, but you also need to find the size of it. I know each size will be 1/2, but that's not very helpful because we need points. So it will be 3 plus 1/2. and then 3 plus 1/2 plus 1/2, and so on. So this is 4.5 because 1/2 is missing. This is 4 and 3.5, like so. So at least this I know students stuck with the interval sometimes. So review this by yourself because that will take me a lot of time to calculate and stuff. But this is how you start. Average value and definite integrals, that's the same thing. So let's do that. Definite integrals. Integrals are the integrals where the limits of integrations are defined. In the formula, the fundamental theorem of calculus says you find the antiderivative, plug the top minus the bottom. That's how I teach. It's kind of easy to remember this way. And capital F is antiderivative. So the thing is, then we taught you the average value. Find average value. And then we give you the function y equals 2 times e to the minus x on the interval 0, 5. The average value is also an integral, but what is the difference? Who remember? V. Do you remember? It's still the integral, but what is different though? Any memory? The average, you should think about this. I always teach it this way. Say you have 5 exams in this class, for example. You want to find the average grade. What do? You add up all the exams and divide by 5. This division by 5 is dividing by the length of the interval from 0 exams to 5 exams. Average means you add up all the things together, and then since integral used to be a Riemann sum, if you remember, that is a fancy sum. But that's just integral. Average means let's average it up by dividing it by the length of the interval, b minus a, like so. So on average, how much did you hike from this mountain to this mountain? You will calculate all the miles you hiked and then divide by the length. That's the idea. So we will going to find average value. AV is not international notation, so depends on the book. Equals, for this particular problem, leave some space. It will be integral from 0 to 5 to e minus x dx. Do not make a pattern here that this is 1 over 5. It's not. It's 1 over 5 minus 0. That's important, or else you'll make a mistake somewhere. Find the length of that interval. From 0 exams to 5 exams, the average will be dividing by 5. Why? Because 5 minus 0 is 5. So we're actually finding a definite integral from 0 to 5 to e minus x dx. And let me slowly go through this to see if you have questions about this. I would kick out the 2 outside. So it's going to be 2/5. Integral of e to the minus x, copy, divide by the leading coefficient. But what is the leading coefficient here? -1. So you change the sign. Usually people don't divide by -1. They just change the sign. But I just did to make it explicit. There is no plus c. Definite integral instead of plus c has a bar from 0 to 5 equals. That is my capital F. We found antiderivative. We write a bar from 0 to 5. Plug the top minus plug the bottom. So e to the 0 is not 0. 2/5.
So can we say that, I'm sorry, 2e to the negative, from 0 to 5, and then you multiply that times 1/5. Is that the same answer? If I go 2e to the negative 0, then 2e to the negative 1, all the way up to 5, and then multiply all those times 1/5. Is that the same?
Looks good to me. Yeah.
Okay, because that's where I get, and then this confuses me with the e to the negative x over negative 1. I see it easier as 2e to the negative, input the number and then multiply that times 1/5.
Times 1/5, I understand. I actually agree on this idea. What he's saying is Why not to calculate this integral separately and divide by 1 and multiply by 1/5? I did not really understand your point with the negative sign. When you integrate, you divide by the leading coefficient. Leading coefficient is -1, so you divide by -1, right?
Well, yeah, it just seems like an extra step when you go to the second part there. You know,
Oh,
like if
that's
I'm
good
only
point.
at 2e to the negative x, why can't I just implement the x into it and get the answer and then multiply all those times 1/5 every time, right?
Yeah, I will do it like so.
Okay, I just wanted to clarify for myself.
I will do it like so. I will do it -2/5 e to the minus x bar from 0 to 5. This is how I see the integral. Minus got kicked
Sure, I
out,
see that, I
2/5
see
got
that too.
kicked
I
out.
just
So now
wanna- Yep.
And then let's see. It's going to be -2/5 e to the minus 5 minus, because the formula says minus, plug the bottom, minus 2/5 e to the 0. Yeah, start with browser. Good. Yeah, I can feel it. My tablet cannot handle more than 2 hours, so that's why I know when to hurry up. And then don't forget,
No,
e
I'm
to the
sorry, I confuse a little bit. It's just what makes
No,
sense
no.
to me.
You're fine. You're fine. Your way is also good until it's correct. Just make sure it's correct.
Sure.
Yeah. So -2/5 e to the minus 5. That is some kind of number. We don't really care what it is. Plus 3/5. Remember, e to the 0 is not 0. I will repeat it many times because people kind of freak out during the exam and put 0 for some reason. E to the 0 is 1. So that is why it's 3. This is 2. That is the good answer. This is the average value. As you can see, the normal integral would not have 1/5 there, but the average to average up the result would divide it by 5, everything. You can do it at the end. That is a good way to do it too. So make sure you do that. How about you? Do you remember we did it in the previous exam? I think. If you have velocity, and then we ask you how far the particle traveled. Let me write down.
The per seconds?
Yeah, remember that. So
Yeah, no, I get confused on the second part. The first one's easy, and then the second part's
velocity is given as v of t, and they ask how far the particle is traveled. Okay, traveled. That is distance, right? Distance usually s of t. How to find that? You integrate v of t with respect to t. So we are doing differentiation. The particle travels, no, I just ask the particle travels this amount of meters in the first 6 seconds, and then the particle travels this amount of meters in the second 6 seconds. So you just do 12. Yeah. No, you just integrate it and plug in. So review that one, because I don't think we can do it now. Review. Let me see something urgent. Let me write down until I forget what to review. Area under the graph is the integral. So we found average area of e to the x, but just area under the. So let's do this review. Remember, from velocity to distance, how far traveled, integrate, review area under the graph, area under the graph, either using those stupid rectangles, which is again only done in America. I will surprise you by this, but none of us ever did those rectangles so tediously. We always, all in Europe and Asia, we just learn integration. Only in America, they torture students with rectangles, 11 points and right-hand points. We always shocked when we teach that. So for you to know,
love
it's like
to
a very.
make things harder than they have to be.
They say they explain the idea behind. Well, fine, explain it in like 3 sentences and move on. Why do you have to put it on the test? So we torture it. It's my 3rd university teaching in America, and all of them doing it here using the book, the same book. So whoever wrote the book, which is Stewart or whatever, they just love these stupid rectangles. But usually we don't do it like this. Area under the graph of e to the x on -2 and 4 is just the integral, you know? Wow, what a surprise. of e to the x from -2 to 4, and you just integrate it. It's e to the x. And you plug -2 and 4, and the answer is literally over here. E to the 4 minus e to the -2. No need any rectangles, left and right. But again, for the exam, you have to review it. It's a very local system of education. So good luck with this. We did not do it. None of us did it. In Asia, people did not do it. I asked. So this is good. This is good problem for the test. As you can see, in area, you just know that it's integral. That's it. And then we did implicit differentiation. And then I told you, review by yourself. This is not too bad because those just formulas, remember? Elasticity and elastic, unit elastic, or inelastic. Review this. I like this. I have videos on this if you want. So review number 3. What else to review? Review elasticity. TCT. That's a pretty cool idea that indeed some items have elastic, non-elastic, inelastic, or unit elastic prices. Elastic, unit elastic, CT, and inelastic, which is, as you understand, the price on milk depends on everything. Not only the weather and climate and even transportation and even prices on gas, but the price on the medicine or electricity, for example. Electricity, whatever they're gonna, so if they make milk super expensive, say $10 per gallon, people will stop buying it. They will figure out how to survive without milk. But if they do electricity very expensive, you cannot survive without electricity. And that is a big difference between which items can be judged on the price because they will lose the consumers, and which one there is no chances to lose them because, for example, if you have diabetic relative, they need medicine. So in my country, they just increased price and people had no choice. You either die or you get the medicine. There was no choice there. And that is very sad when they do it this way. So that is a very cool idea behind this. Learn how to do it, how to work with this with the given equation. Q equals, for example, D of P equals 300 over P plus 1. And the graph looks pretty cool. I remember the graphs and stuff. So find the equation for elasticity, E of P. Find the elasticity at the given price. For example, P equals 1. P equals 1, starting whether the demand state if the demand is elastic, inelastic, or has unit elasticity. And finally, C is the values of for which total revenue is a maximum. So maximum revenue, basically. And you know how to do that. Well, the values which can maximize the revenue. A, B, C. Do this, I can give you the answers, you can compare. 5P over P plus 1. At P equals 1, it is 5 halves. Because it's greater than 1, it is called elastic. And then you maximize, know what unit maximized the revenue, it gives you 0.25. Those are the answers. So you have now to work on this, that is good. Let's see, I think we did really good. Is there anything else I lost? No, differentiate profits, cost function, how fast, units, demand elasticity, I just mentioned right now. Implicit differentiation. Related rates, integral, area, which is still integral. We did this, average area, we did that. Use substitution, integration by parts. Riemann sums, unfortunately, there's one problem with Riemann sums there. So make sure you review this. we did at the very beginning, equilibrium point, surplus, consumer surplus, producer surplus. And the final topic you guys learned was improper integrals. We did that as well at the beginning of this video. Nice. Wow, in 2 hours, we actually did everything I wanted to do. These, I think, is doable to do by yourself. But post in the forum if you need help with this. And I can send you my videos on these two. What do you think? We did quite a lot. And you
How
know,
many problems are on the test?
22.
22?
22 problems, 120 minutes, you know, have some aroma oils if you need to come down, a spinner. I always tell my students have a spinner. The fidget.
I did have a question. What's the difference between integration and antiderivative?
Oh, same thing. That's a good question. It's also American way of teaching it, surprisingly. The first, in American calculus book, they first introduced antiderivative without ever mentioning that that was integration. So that was really, really weird to me when I was teaching this. Antiderivative is undoing differentiation. So what was the integral of 2x? And we would ask, can you guys guess? And they were like, well, duh, it's x squared. And we say, it's not only x squared, it's x squared plus 5, x squared minus 7, so it's x squared plus c. Undoing the derivative was called antiderivative. And then, boom, it's like out of nowhere it says, oh, actually it's called integral. You know, and we say it's integral. And then integral were divided into 3 categories. First 2 of them, indefinite integral, definite integral, and now recently you will learn about improper integrals, something like from 0 to infinity. And there are more actually the interesting integrals which we don't cover in this class. Good question, yeah.
Okay, thank you.
More questions? What do you think?
I have a question about the A and B placements, because I know they represent the X and Y axis. Because I know there was a couple of times when I would get have the tutor help me, but they would have the Y value at top and the X value at the bottom, and then someone had the X at the top and the Y at the bottom. Would it make a difference when we subtract, when we use that formula, when we do the B minus the F of A minus the B of A, if it's in the X or Y value?
Yeah, I think I understand your question. Always do bigger minus smaller. That's the idea.
Okay.
So let me write down if it stopped jumping. Oh, wow. Let me write down. So that's a good question. And we do integrals both x, y, x, x, and y, y. So that's how you do it. Integral of f of, let's do small, f of y dy from c to d will be, just remember, you find antiderivative, plug the bigger one first. And the bigger one is the one at the top, whatever it is. So it's going to be d minus plug the smaller one. That's why I say top minus the bottom. In y case, it might be right minus left, top minus the bottom. So, and then if you do it with respect to x, this thing is exactly the same. The idea is the same. From A to B, plug the bigger one, which is b minus this, not the number bigger one though. You should know that it's not necessarily the number is bigger by the value. We just know that b is somewhere located bigger than a. So just plug that, bigger minus small. That makes sense if you think about how far did you travel from home to work. When people ask this question, you take work minus home. You always take the last point minus the first point to find the difference. That's
I didn't even think of it that way. Yeah, but so there could be a possibility that we would substitute that D for either our X or a Y, just whichever value is bigger.
Not the values, always put whatever was at the top will go first. Whatever goes at the bottom will go second. That's how.
I just thought that those represented one of the X points
maybe
and one
on
of the Y
graph
points.
it will show you and it will be better. X is A and B. You're disappearing and I'm not sure if it's my fault or not. You're jumping, sorry, just a second, let me then tell you. X is A and B, C and D is Y. So from right to left, which is still bigger minus smaller. From top to bottom, which is still bigger minus smaller. That's how you do it. So just make sure you understand whatever was bigger minus whatever was smaller. You were saying something, but you glitched, at least in my case.
Oh, no, you explained it to me. Thank you.
Okay, yeah, good.
Thank you.
That's good. Can you go through the steps of the last elasticity problem again? I'm not understanding how you got the answer. I just copied the answer from the sheet. I kind of need to go, to be honest, because it's been already 2 hours. That's why I hoped you can review it by yourself. But I can post you if you want materials for this, so you can go through. Elasticity of the demand are nice topics. It's just kind of lots of steps there. So let me post everything, and then you guys will have good notes anyway, so that's good.
Okay.
We got
So
4
everything you went over?
Yeah, yeah. I went there through everything, and I listed everything into review, whatever I did not went over.
Okay,
Mhm.
so this is all on a test. Okay, so we just need to go back in the video and check it
Yeah,
and see.
exactly.
Okay,
This video is amazing. So whatever I just said, if you practice it, it's amazing. The best if you can unlock the practice exam, but in this video, I just gave you everything you need, even if you don't unlock practice exam. But practice exam is 5%, so you kind of want to unlock it.
okay.
Thank you so much. You're a great teacher, and I really appreciate all the extra steps you do. I know,
I'm so happy.
but
Yeah.
no, you really are more helpful than most teachers. So I just wanted to let you know.
Agree.
Thank you. Don't forget to
Thank
put it in
you.
my evaluations. They close
Yes, I will
tonight.
definitely. No, I've already talked to a couple of people about you, like in positive ways.
Oh,
So
that's good.
I promise you do more than most.
Oh, thank you. Yeah.
So-
Don't forget evaluations are important. That's
Yep,
our
I'm
official
definitely
proof
doing one.
that I did not I
Yeah.
did not slack out. But no, my
Yeah.
PE students always tell me my reviews are very good. So I was always sacrificing 2 hours of the evening for the review.
You work hard,
And-
and we do appreciate it, even if people don't tell you every time.
Thank you so much. That's definitely made my evening.
All right, thank you so much.
Thank you.
Good night.
Have a good night.
Thank you.